Good morning. Welcome to another video for continuity. If you are given a question like this, find all the values of a and b such that the function f will be continuous on R. F of x is called sine x, ax plus b, and x to the power of 3 for these ranges. So the critical ranges which we are given are, we have 0, we have 4, and our function varies in these ranges like this. Here we have the function for less than 0, it is sine x, and for 0 up to 4, it's ax plus b, and for greater than 4, we have x to the power of 3. And referring to the previous video, we said that if we want to find the limit as x approaches 0 from the negative, we are approaching 0 from the negative, and here will be 0 from the positive, and 4 from the negative, and here will be 4 from the positive. So what we want, since we are saying that this function will be continuous, it means that all the 3 points hold, which are A, we are saying the limit, it's supposed to be f of a exists. Then number 2, it's the limit as x approaches a of f of x should also exist. And then number C would be a limit as x approaches a of f of x should be equal to f of a. So all these 3 points should hold. Having this in our mind, we can actually see that the limit as x approaches a of f of x is equal to f of a. So we are actually assuming that all these 3 points hold for this one, because we want f to be continuous on R, right? So here we now consider our points, our f of x at our point. So we say the limit as x approaches 0 from the negative of f of x is actually equal to the limit as x approaches 0 from the positive of f of x. The reason being, we assume that it's continuous. So maybe for clarity's sake, we just can say assume that f x is continuous on R, right? Then here at x is equal to 0, we're going to consider the functions which are defined before 0, which is sine x. So here we have limit as x approaches 0 of sine x is equal to limit as x approaches 0. Approaching 0 from the positive, the function is ax plus b. Ax plus b. And if we substitute 0 there, we get sine of 0 is equal to, that is a by 0 plus b. So it means that 0 is equal to b. That is the first solution. For the other part, we are now considering this point 4. So we are saying limit as x approaches 4 from the negative of f of x is equal to the limit as x approaches 4 from the positive of f of x. This is actually equal to 4, we are approaching from the positive. 4 from the positive is x to the power of 3, and 4 from the negative, as you can see, 4 from the negative is ax plus b, and 4 from the positive is x to the power of 3. So it's ax, limit as x approaches 4 from the negative of ax plus b is equal to limit as x approaches 4 from the positive of x to the power of 3. So what it means is we just substitute there. This one there's no need for us to put from the negative and from the positive, since we have already considered the function. So this one you just have to substitute. So you have 4a plus b is equal to 4 to the power of 3. So this, we know that b is equal to 0, so 4a is equal to 64, which is a is equal to 16. So that's it for this question. So the question was reading, find the values of a and b such that the function will be continuous on R. So if our a is equal to 16 and our b is equal to 0, this function can be continuous on R. So the resultant function will be f of x is equal to sine x, then a is 16, and then the other one is x to the power of 3. X less than 0, x 0 less than x less than or equal to 4. Then x greater than 0, x greater than 4. So that's it for this question. So this function is actually continuous in R.